that's it. X and Y are multiplied by this PSF thing, but Z isn't. It's just multiplied by negative 0.01. And so the matrix, the quote-unquote projection matrix he's using is, wait, where's the W coordinate? And W is just left at 1, I guess. So which is also, so that's just 1? Okay. And so the matrix, quote unquote, that he'd be using. Hold on, let me do this. Technical difficulties. There. There's some shortcuts to make my keyboard faster. The matrix will look like, wasn't trying to do that though. Are we back? Great. I'm gonna just write out the first row. 2, well, this thing is what X gets multiplied by. Then 0, 0, 0 would be the first row. The second row would be a 0 here. Then this with whatever divided by Y. The 0 would be just Z times 0.01. So 0, 0, 0, negative 0.01. And then the W row will be this. Okay. So how does this, wait, where's the 1? Okay. Yeah, I think this makes sense. Because the W coordinate, wait, don't do that. Is then a vector something like, say, 1, 1, 0, 1? Where would that get mapped? If this was a column vector, it's 1, 1, 0, 1. Well, the x coordinate would be multiplied by this. The y coordinate would be multiplied by, would just be 1 times this, which is correct. The z coordinate, it's a 0 in this case, but it'll be multiplied by only this. The negative 0.01. And then the w coordinate will just be multiplied by, will be 1 times 1. So this is his quote-unquote projection matrix. The question now is to see how this matrix maps onto what a projection matrix actually is. R and T. What is R? R is right and T is top. So these variables encode information about the width and the height of the frame, which this is also doing. What is this? This 16 divided by 16 minus z is messing everything up. And the fact that my music is talking. Can it stop doing that? And the fact that these entries, let me just put this on the same screen. these entries aren't accounted for in the matrix over here. These entries aren't accounted for in the matrix over here. Like, why is there a 1 here? Yeah, here's what I'm going to try to do. I'm going to remove the current shader logic and replace it with just multiplication by this matrix. And then try to work toward this matrix from there. So first let me see if this still runs. And it doesn't. So what did I break? Oh, all of this. Yeah, that'll break it. And this should be commented too. Shared matrix. Let me see if this runs. Great. So now I'm gonna try to just do this. This should be the same thing that's happening here. Except maybe I need a 0.0 here. Actually, this might have to be 0.0 as well. Because type inference is operating system dependent in OpenGL. So with this, I may be able to comment all of this, uncomment this, and then compute it using a quote-unquote matrix. And it didn't work. Undefined variable result. Oh, I should make it a vec3 or vec4. And do I need semicolons? When I was writing this, I wasn't even writing it to be C code. I was just writing it. Or shader code. And find variable x and z and y and z. Oh yeah. So this is point .x. And this is just a 1. X, y, z, and then just 1. Okay. And we have a problem with z. Where? Oh, there it is. Normally it would tell you the line, but since all these files are being pre-processed, there's no way to find out, or there's no easy way to find out how these lines map to these lines. But anyway, that works now. It's doing all the same computations. I'm gonna remove the axes. Yeah, for now. Maybe I should just do this. Maybe I should just do this with the stroke as well, and then come back after that. Because it's kind of confusing for the stroke and the fill to behave separately from each other. Let me see. My guess is that the shader for the stroke will do something similar to this. Let me figure that out for sure. Stroke. Now look at the vertex. So more or less the same thing. Position point into frame and rotate point into frame. I guess this is just a random constant that it gets multiplied by. And rotate point into frame. I guess this is just a random constant that it gets multiplied by. And then if I look at the geometry shader, the 270 line geometry shader, this line is also in the shader for the fill. Get reduced control points. Oh, this is going to be pretty annoying. Well, maybe it won't be. Adjust the stroke width based on the distance from the camera. An absolute value of a dot product. Isn't the dot product already Oh no, it's not. It's just it's scalar. This might be hard to convert. Because the scaling logic is integrated into the algorithm. Find UV conversion matrix. Which I'm also not sure what that is. It's still at the very end. It does the same function, get GL position, which is the same function that's used in this geometry shader. That's what this is. Or yeah, that's what this was before I took it apart. So a lot of the projection matrix logic is taken care of just in this function, but not all of it, because this perspective scale factor, which takes the focal distance into account, that's going to do something different. So I'm not going to try to modify this. I'm not going to try to do them both separately. I'll focus on just the fill for now, because that could get really hairy. So where's the shader I was working on? Here. Okay, so let me try to make this into a matrix. Which means I have to know how to declare matrices in OpenGL, which I only sort of do. But I can do mat4 projection matrix. And each index is going to index the column. So I can say mat4 and 0 equals vec4. It's basically going to be these. So this. And then 0, 0, 0. I guess I'll just go down the line like that. So the next one will be 0. So 0. The next one is this, but with a Y. And I have to say point.z. Then 0, 0. This is 0, 0, negative 0.01, 0. Then we have 0, 0, 0, 1. I think this is the projection matrix. So now I'm going to try to say that result is projection matrix times the homogeneous version of point, and then not do this. Maybe now I can just basically use this projection matrix, which is what and then not do this. Maybe now I can just basically use this projection matrix, which is what I'd like to do. Okay, but I did something wrong. What did I do? Size of dimension cannot be less than 1. That's weird. Where is the size of a dimension less than 1? I'm gonna go back to this. Okay, so that's how it was before. I should be able to just declare the projection matrix, I think. Okay. And I should, I think, be able to just set this column. Nope, something's wrong with that. Size of dimension cannot be less than 1. And some error unexpected equals. Is this any different from this? Whatever at 1. Oh, is the indexing starting at 1? No, that's not it either. It's even 0 from what this says. Oh. So I'm going to try doing something simpler. What happens if I try to set the first column to just zeros? And I do this. Okay, there's something else to setting matrices. Size of dimension cannot be less than 1. I wonder if this code even works from this. Oh, this isn't mat4. This is supposed to be projection matrix. Okay, so then that works. Great. Okay, then I can do that for all of these, hopefully. Okay, so this is just declaring the matrix, and that works. And I'm going to multiply by this matrix instead of doing those manual computations. And this is the same thing too. Okay, I consider that to be progress. Now I wonder if I can change this projection matrix into the one that's used with the other shaders. Where would I even pass it in? I think what I have to do is probably go to OpenGL renderer. This is where I'm passing them in. Maybe I'll just set another uniform to like manual projection matrix or something. I think I can just declare that without an error. Okay, so that's good. Then I'm going to try to pull that matrix from Python. The way I'll do that is like this. And this will be like manual. Okay, and then pretty much I can just copy this. Okay, and then pretty much I can just copy this. Now, a few things. What is the frame shape? I think it's just like config at frame width. Let's multiply by 2 divided by that. Frame shape dot. Yeah, I think it's just config frame width. I think it's this and then frame height. As for what z is, I don't know. Is this the z of the point? I guess that would make sense. Oh, so then this shouldn't be... Oh no, but x is being multiplied by this, not added. So why would the x coordinate be multiplied by its own z coordinate? I think that's a problem. Because this matrix relies on knowing data from the vector. There's data from point multiplied into the vector, transforming point. I guess I can see what happens if I just multiply this or replace this point by point dot z with like a constant. My guess is that it'll go horribly wrong. What if I just made this 10? Okay, so then the camera's scrolling doesn't work, which makes sense. I don't know if there's a way to do this without using a real projection matrix. Well, maybe this is... Well, not a good thing. But maybe this is an opportunity, a reason that I should try to use a matrix with this form rather than one with this form. Far plus near over near minus far. I'm just gonna have to make up variables for the far and near planes, I think. But if I take out this and this, since I don't totally know what they are, does that just make it... Oh, it matches perfectly. That's kind of weird. Although the camera scrolling doesn't work. Okay. I think that actually... No, that doesn't make that much sense to me. But I'm glad it worked. Near divided by width. Since this is near divided by the right, the distance to the right plane, and this is 2 divided by frameshape.x, the distance to the right plane is half of this. So this is 1 divided by the frameshape.x over 2. So the near and far plane are both right in this matrix? Which doesn't make that much sense. Okay, I'm just gonna try to continue to make the matrix more similar to this one. Okay, so that broke everything. Putting that -1 there. I'm gonna see what happens if I replace this -0.01 with a ratio of far over near. So I'll say float. I think float is an OpenGL type. A ratio of far over near. So I'll say float. I think float is an OpenGL type. Yeah, it's just float. Near equals like 1. I don't have far equals 20 or something pretty large. Maybe 21. Near minus far. Near is a small number. Far is a larger number. Because it's distant from the camera. So this will be negative. But it has these very close. I think it feels like all of his computations have the goal of having the near and far planes be almost the same thing. But I'm going to try to run this again. I'm pretty sure things are going to start breaking pretty badly from this point. So I'm going to work on another copy of this. And here I'll say far plus near. Basically just copy this in. Near minus far. And then 2 times far times near. Near. Divided by this near minus far. And then this is the -1. Whoops! What did I do? Oh, I put Control Z. That should be -1. Oh, wait. No, this is totally wrong because OpenGL, these are columns. These are supposed to be columns in OpenGL. So that's not what it's supposed to do. That actually makes me wonder. No, that's fine. But the first column is the same, the second column is the same, the third column, it should be this and then a -1. That should be a -1. And then it'll be 0, 0, this thing. And then 0. Did I even copy this right? Okay, so this ratio, 0, 0, 0, 0, this ratio, 0, 0, 0, 0, far plus near divided by near minus far, then -1. We have 0, 0, 2 times far times near divided by near minus far, and then 0. Okay. Well, it is there, which I guess is something. It's super small. Wait, hold on. It's still bound by those far and near planes. And it does this staticky thing. And the perspective is all out of whack. Darn. wonder what could start to remedy these problems. So for one thing, the x and the y coordinate being small, I guess what I want to do is multiply them by a larger number here. And the z coordinate gets multiplied by this, then added to the w coordinate times this. And the z coordinate, or in the w coordinate rather, gets just this -1 times the z. Okay, so I'm gonna make this a 1. Make this a